All right, so my name's Amal. I'm going to be talking about robot reliability, both sort of from the more best practices and philosophy point of view, as well as sort of a bag of tricks of just kind of handy bits of knowledge for keeping things running during the season. So a little bit about me. My name is Amal Iyengar. I'm an electrical engineer at the Johns Hopkins Applied Physics Lab. I mentor 888 in Maryland, and then my old team, I still stay in touch, mentor online 4795 from North Carolina. I've been CSAing since 2017 and inspecting since 2018. When I started doing this, I think the one video of a robot from 2014, I don't believe the robot is on. So I've sort of been on the side of, being that kid behind the glass who is just waiting for a match to end, seeing their robot not do anything. So it's really important to me that, my students and everyone else gets to, actually be able to see their robot do what they spent hours and hours trying to get it to do. So just to start this off, right? 888 played 44 matches across 3 events, and we paid $10,000 in just registration for that. Ignore travel, robot parts, whatever, right? So that's 110 minutes of match play. Most of you spend more than 110 minutes during build season on average per day working on the robot. That is $227 per match and $1.50 for every second your robot is on the field. If you don't move in a match, that is a $200 failure. If you don't move in a match or you have a problem in a match that costs you a trip to playoffs, we're talking, easily over $1,000 worth of failure in terms of the match play that you're paying for, right? So you look at the best teams, they're working every single match. Citrus Circuits has made it to Einstein for literally a decade straight now. There are things that Citrus does that I don't know how to do, that I can't replicate, that most teams can't replicate. But I don't think that reliability, especially of their electronics, is one of them. Everyone has the same control system. Everyone has the same Rio, PDH, access to all the same components there. So I think that this is an area that we really can level the playing field. I think that every team can have 0 on-field controls failures. I'll note, I think 888 got close to that this year. These spots, not so much. So still a lot of work to do. But my dream is that every team is driving in every match from the first event of the season. So sort of the background, the ground rules is, okay, just test the heck out of it. Test incrementally as soon as you get something that is testable. A single swerve module, a drivetrain, a shooter with no intake, right? Test what you have when you have it. Test more than you think you need to, and put your robot through hell. Test in conditions that are far worse than what you will compete in to see what shakes out for the real event. The second piece is what I call having a sense of danger, which is just knowing your robot and understanding it well enough that you can feel when something's wrong and you listen to that and actually follow through with it until you fix it. And the third thing is just the less stuff that's on your robot, the less things there are that you fail, right? You build simple robots, there's just less that can go wrong. So starting with test, right? For a lot of teams, I know for myself as a student and for a while as a mentor, the event was really the first time that we ever got to actually run the robot. But we do better now, right? Robots get hours and hours of runtime pre-event, starting from as soon as it's a drive base, right? As soon as it's a drive base, as soon as any mechanism goes on, each of those, we carve out time that we are not working on the robot to add more stuff. We are just testing what we have. And one of the ways we do that is we make hard decisions to have things testable early, right? We choose not to do stuff. We choose to sacrifice certain mechanisms to have something testable early. So we have at least one thing that we know works rather than working on 5 things in parallel, trying to throw them all together at the end and, hoping that they work. You want to test in really bad conditions, right? So the frame damage we had there, that was from a scrimmage where we just told, 587, a friend team, to just bash us as hard as they can, right? Play harder defense than honestly we'll probably see until district champs. And they did. Things broke. We fixed it. Those things didn't break during the season. Your robot works well when it's kind of, running in a match for the first time. Okay. How well is it going to work, in back-to-back lower bracket matches or in an 8-minute turnaround from finals 1 to finals 2? Run the robot for a long time, run it hot, see if your motors fail under heat, right? Put your drive team, give them situations that, you think that they'll deal with and situations you think that are worse than what they'll deal with, right? So I think eSpots gets most of our competitive edge just from practice, software, and reliability. I don't think the robots that we build are, have a higher ceiling than a lot of other NC teams. I just think we tend to build them faster. And our reliability still isn't great, but because we tested so much, because we got scoring by the end of January, and we did basically 2 to 4 hours of testing a week starting, I think, second week of February, we caught a lot of stuff, but clearly there was still more to catch. And when you're testing, one thing I hear is, someone's doing drive practice, they say, I don't want to drive it too hard, but, so we can, I don't want to break the robot before the event. If you break it in practice, it's going to break at the event. So I say, go for it and figure out what's going to break and then fix it so it doesn't happen at an event. So when you're doing drive practice, you should not be worried about breaking the robot. When you're driving on the field, ideally, you shouldn't be worried about breaking the robot. It should have been tested to the point that the driver knows they can send it as hard as they need to, and the robot will tolerate it, either because of software limitations or just how robustly it's built. So second piece is having a sense of danger, right? And this just comes from how well do you know your robot? Do you know what it sounds like? Do you know what every mechanism feels like? How much play is in that mechanism? How much friction is on a swerve module when you turn it by hand? If something just feels wrong or different than it did yesterday, listen to that feeling and investigate it. I think 2022, I heard some clicking noises out of our drivetrain a couple of weeks before an event. And I was told by my, I'm an electrical engineer. I don't really know mechanical stuff. Our mechanical lead said, robots make noise. It's fine. Q1st match 2022, that is a GIF of us driving across the field on one set of wheels because the snap ring fell out. And then when they replaced the snap ring, the clicking went away. Funny how that works, right? So, but it didn't sound right. It didn't sound usual. It wasn't doing that yesterday. When you ignore that, you do so at your own peril. This requires a lot of practice, a lot of knowing your robot. Part of it is on the driver. They'll have a good feel for it, but also everyone else, right? So how do you develop this, right? So one important thing is anyone can bring anything up, right? It doesn't take a genius to notice, hey, a zip tie's loose. Hey, that Spark Max is blinking weird. Listen to anyone and everyone because anyone can point things out. And a lot of this comes down to discipline. And you have to develop the discipline to not just say, it's fine, that just happened, it's not a big deal. We've been seeing that, it won't break at the event. And this is kind of a known thing in software development where the longer you wait to fix something, by far, the more costly it is. And as a corollary, you have less time to fix it, right? Week 3 of build season, you got a lot more time than 2 days before an event than you do between matches at an event, right? There's always too much to do, right? There's always more things that you want to do that you're going to have time to do. If reliability isn't baked in and part of your schedule, and if you think you don't have time to make it reliable, it just means you're doing too much and you need to build a simpler robot, right? And also just when you see small things, take those seriously because they're often a sign of bigger things, right? 8-8 shooter had a lot of friction in 2022. We kind of ignored that, but it ended up basically meaning that we could not reliably shoot high in 2022, which meant that we were not competitive after week 1, right? We had also like a Rio would disconnect every so often. And since it kind of worked okay, it was just chalked up to stuff's being weird. But we went to the event, this was a few years ago, and it ended up being that the Ethernet on the Robo Rio was actually having intermittent failures, ended up completely failing, right? So small failures are often trying to tell you something, and you just got to listen to those things and not just say, "Oh, that's weird. Let's move on so we can do more stuff, get the fun things working," right? By the way, questions or other thoughts, just put them in chat or unmute at the end. And something I see commonly is people applying band-aid fixes when they really shouldn't be. And I kind of an example of this a few weeks ago. 8.8 had a Spark Max where it was giving an error blink code saying sensor fault. We couldn't quite figure it out. It was on our swerve module. And we tried reflashing it, and that looked like it fixed it for a bit, right? And then it popped back up a little bit later. We power cycled it. We couldn't figure out exactly what was wrong, and it looked like it worked okay. Then it was like 2 days before Bob. We figured we didn't have time to tear the module apart and do all of that. Except we ended up tearing the module apart at Bob when it failed there, and turns out that encoder was just I think that encoder had basically completely failed, right? So we ended up taking time when we definitely didn't have it at an event, instead of a few days before when we were still time constrained, but not as much as you are at an actual event, right? And that was Bob. It was an off season. If that's a real event, that's a much bigger deal. So if something fixes something, but it shouldn't, or that it's kind of just a temporary thing, look harder for a root cause and actually, again, have the discipline to not work on doing more stuff, getting that cool auto routine working, and just fixing the underlying problem, because it will pop up again, and it'll pop up again when you really don't want it to. This is pretty self-explanatory, but less things, less failure. Every component and connector is a failure point, right? It doesn't matter what. So at the less things you have on a robot is fewer things that could fail. And I think, eSpots has done a very good job the last few years of having competitive robots without having to do everything, right? Last year, we couldn't score high cones. That was a trade-off we chose to make for simplicity. And that robot still ended up a little more complex than ideal, but that's okay. But just to reiterate, if you don't have time for reliability, if you're not baking it into your schedule and saying, we need to start testing very quickly, to be able to make sure that this thing works every match, then it means you're doing too much and need to downscope. And it's not, it's not a failure to say we need to do less, right? You want to come to an event with the best robot possible, and the best robot possible is the one that drives every match. So kind of a tip for this, there are 3 week zeros in Chesapeake. We're hosting one at Gleno. There's one in Richmond and one in Blacksburg. If you can get into those, and even if you can't, set those as dates that you are ready to compete, right? Have that be your forcing function of, no matter when your first event is, show up to that with something that you would be okay competing with. It might not be your final product, right? In 2022, eSpots was about a week out from our week 0 scrimmage, and we looked at the schedule and we said, we can have a shooter, we can have a climber, we can't have both. And we just said, we're not climbing at week 0. We'll do it after that, before our week 2 event. So by putting an earlier forcing function of week 0, that's at least 2 weeks before your first event, if not more, you force hard trade-offs and you force yourself to have something that works. And by running it, weeks before your first event, that is usually good enough to ensure that you have something that works reliably. This next bit is risk assessment. I think any of my students will tell you that my favorite words in engineering are risk reduction. So, and I call this having a healthy paranoia, because I want you to be thinking about every single thing that can go wrong, write it down, and then think about it in terms of, okay, how likely is this to happen? What's the impact going to be? Especially when you're trying new things, right? So, for us this year, it's switching to swerve, right? There's a lot of risks inherent with that we need to look at and figure out where these things can fail. And then, take risk reduction steps. If we know something is likely to happen and it's really bad if it does, then let's do everything we can to prevent it, right? If it's never going to happen and we're honest that it's never going to happen, then it's fine. We can, we can choose to deprioritize that. I've got an example here of a risk reduction report one of my students put together last year about swerve, right? We went through and we basically came up with major risks, mitigation strategies, and what we plan to do, and some things that we weren't too worried about. Be creative about this, right? Exercise your brain, think about what are all the random things that could fail, and write about it. Think about it, talk with your teammates about it, and then deal with those before they happen, ideally. And if something's already failed, I don't know how many times something's already failed, and I think, yeah, that'll never happen again. Yes, it will. If you haven't fixed it, yes, it will. Then, okay, how do you bake reliability into your design, right? One piece of design things to be easily serviceable and replaced. If you know something, especially if it's a potential failure point or very, very important, that includes swerve modules. If you have a module failure and you have 8 minutes before your next match, you should have a plan to put an Omni on there, or have a full swerve module you can swap in 8 minutes. So, bake that into the design process and think about it in design review. Include electronics in your design review. I would lay out your electronics at the start of the season. You can kind of just say, hey, we're putting our Rio, our PDH here, and have that be a constraint that your designers work around. Or you can have your designer say, hey, this is the allotted space. Is this okay with you, right? This was eSpot's 2017 robot where nobody was asked, and then electrical was given a 1 foot by 1 foot by 1 foot box to put everything in. That season ended on an electrical failure. Shocking. So I think what happens with a lot of designs is that there are things are potentially problematic that you just want to put in the back of your mind. And I would encourage you to not do that, and to ask yourself and others, what will fail on this first? I ask that question in every eSpots design review. I don't know the answer. I'm a complete idiot mechanically, but it forces the thought processes, and it usually catches a few things that would have failed just by asking the question and forcing a discussion on that. Low CG is always good, right? There's a lot of tippy robots. Try not to be a tippy robot, right? Bake it into your design process from the start, where we're putting electronics, where we're putting our center of mass. As you add things to your robot, consider the effect on those things, and make sure that when you add, you add one mechanism, okay, great, that's maintainable. Then you add another one next to it, and suddenly you've lost all access to that, right? So consider these things at the start of the season and throughout the design process. Checklists and systems checks. So really, again, this just comes down to discipline, right? It doesn't matter how smart you are. This is a good book called The Checklist Manifesto. It's about, checklists saving lives in surgery, where you have a bunch of very smart people who still need checklists to make sure that they don't forget important stuff, right? I'm a reasonably smart person. I've had an FTA slam a tablet on, our driver station glass saying turn on robots, because it's not about smart or committed. It's just anyone can forget things, right? So do systems checks, have a checklist, actually stick to it, and have the discipline to do it before and after every match, and not just say it'll be fine, right? A lot of, honestly, so much reliability just comes down to, one, having the discipline to do it, and two, having the humility to admit that things can and do go wrong. So questions on any of this before we kind of go into the second part of this, which is just kind of a rapid fire list of reliability tricks.
Okay, if you're doing both the pre and post match systems check, so the post match systems check be the exact same as the pre match systems check, or is there anything different that you should do only in the post match systems check?
I think it should probably be the exact same. I think it may depend on your robot and your team, but I'll talk for us, right? We have our drive team do the pre-match systems check. just, because they're the ones who will be controlling it, right? The post-match, after the match, we have our drive team debrief the pit crew on anything technical that happened during the match, if there's anything they need to look at. So the post-match, I think it should be a little more rigorous on just visual inspection, but actually, running through the robot functionality, I think is the same. I also think that I don't know that I've seen anyone do this. I think a lot of these systems checks can be automated. There's that test mode in your robot, and I'd love to see a team have something that automatically spins all their motors, make sure the encoders are all going in the right directions, make sure that, when you drive something to the limit switch triggers and the current spikes or whatnot. I don't know that I've seen anyone do that. If anyone knows someone who's done that, that would be really cool. But it can be automated. It's just everyone does it manually. Any other questions? All right, let's move on to bag of tricks, and you get pop questions in chat or afterwards. I'm going to go pretty quickly through this because I'm going to be posting these slides, and I think there's links in almost all of them. Some of these, most of you probably already know, but just good stuff to know. Use power over Ethernet, right? Don't just plug your VRM into the barrel jack of your radio. This is like one of the most common failure modes. The barrel jack is unreliable. You go over a bump, you take a hit wrong, it'll disconnect for a half second, and your radio will reboot, and you're sitting dead on the field for 30 seconds, right? Radio power module is great. If you're using that, plug that into the PoE port. If you're using the voltage regulator module, then do double power. Use a 12-volt 2-amp slot to go both into the barrel jack and power over Ethernet. Battery practices. So MK battery and Duracell batteries are the recommended battery suppliers. There's a few others that may or may not be good. These are kind of known good. Duracell, I think some people say they're the best. They're a little bit expensive. MK batteries are, I think, probably best bang for your buck. And if you call up the MK battery office, just Google the phone number, and then say you're an FRC team, they'll sell you batteries at a discount for free pickup. Interstate batteries are not so good. Those, and all of these batteries are kind of meant for drawing 2 amps for 10 hours, not drawing 100 amps for 2 minutes. So these batteries, they're all rated, they're all just fine at what they're meant for, but Duracells and MKs tend to be the best at the kind of crazy loads that we put them through in FRC. The 900 battery paper, which I will link, and put in the slides, has a lot of very good best practices, including using grasshopper nuts, which I think Press handed some of these out at Chesapeake events last year. These are very, very nice and good ways of making sure your battery lugs stay on. Use new batteries. Ideally, what we try to do is we buy, about 6 new batteries every year. We make sure those are the only ones we use in competition. That may not be achievable for everybody. But if you're doing that, if you're not buying new batteries every year, try to use batteries that are from the last few years that you've checked on the battery beak and you kind of know are good. And then keep them plugged in or fully charged. A lot of batteries died because they were left uncharged over COVID and got fully discharged and basically were never recovered. Personal opinion, I don't like hard mounting the SB50, the kind of power pole connected to the battery. I think that leads to decreased shock tolerance. But if you do, make sure you use zip tie or clip the battery power pole together. Do that regardless, but personal opinion, there are different opinions on that. If you're worried about crimping battery cables, just buy them from AndyMark. Like I said, it's some money, but again, we're talking $200 a match, right? So it's okay to spend money on reliability. If you've got the crimping equipment yourself to do it yourself, that's great. But these are things that you should not feel bad spending money on if it is the best way for you to have a reliable robot. More battery stuff. get a battery beak or $100 on AnyMark or CTRE. Good way to use your AnyMark voucher. A fully charged battery will read about 130%. That's confusing, but if you battery beak something, a battery, and it says 100%, do not use that in a match. It should be above 120%. Ideally, internal resistance below 0.018 ohms. So yeah, battery beak, great tool. Get one. Check before every match. Don't hold the batteries by the wires that can do really bad stuff to them. And make sure you've got another battery on your robot cart. You know, sometimes you turn your robot on and then the field breaks, sometimes because we break it. And then you're just sitting there for, 20 minutes and your battery's draining. Just have a second battery with you ready to go so that if you end up doing a bunch of systems checks in the cart or your robot's in the field for a while, you have that ready to go. You don't need to sit there, send someone run to your pit or run with a bad battery in a match. Protect your breaker. I've had robots get turned off because a game piece fell on them or another robot bonked them. That's really, silly. Don't let that happen. This is a good breaker shroud design that I've linked. Make sure your breaker's accessible, but protect it with a shroud. If you don't have this and you really need this, something in the next 5 seconds, or old duct tape works, but you're all attending this and should just print this shroud. The OptiFuse breaker in the kit of parts is bad. It has multiple known failures. So this is the battery. This is the breaker in the kit of parts. Do not use it. Use an old breaker sold by Bussman or buy one. They're on AnyMark. They're on other vendors. Make sure you got the part number right in the rules. And then make sure you use nylon lock nuts to secure the terminals to make sure you have a good connection. So breaker you've gotten in the kit of parts last year, maybe 2 years, do not use. It is way too failure prone. Port 2 on the radio, also bad. So this is actually a chipset bug from, I think, Qualcomm maybe, where every so often what you plug into the second port of the radio, the one farther away from the barrel jack, just will not come up. It'll probably come up if you unplug it and replug it, but don't mess with that. Just don't use it. Use a network switch. This is the one that we use. I'll put a link to that. It's powered directly from the PDH, which is very nice. Plug port 1 into the switch and then plug everything else into the switch. Just leave port 2 entirely out of use. Because if you've got your limelight plugged into that, it just won't come up in some matches and you won't know why. This hasn't been relevant since 2022, but the RoboRio's I2C port is bad. So the main I2C port, the 4-pin connector on the RoboRio, every so often there's a bug there where if you use it, it will basically completely lock up your RoboRio with no way to recover it except to physically reboot it. So you can't reset it from the driver station. If it happens, you're just gone. So the expansion port I2C is, in my opinion, good enough. It's got a very, 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 very low failure rate. It's non-zero, but very low. In my opinion, it's good enough. If you want really to reduce all of the risk, you should use a different device entirely to do I2C. I've linked to a Raspberry Pi Pico UART to I2C bridge. So mainly I2C has been used in the last few years as a color sensor, but it's a common enough protocol that it may be used for other sensors. So if you're using something with that, at least use the expansion port I2C, not the RoboRio. Metal shavings are bad. This is fairly obvious, but still every year. Some freshmen in 2020 were a little lax on this, and we had to sit out a couple matches replacing our Rio. And one of those matches was a 0v3, and our human players still got penalties. Do not recommend. So E-tape over literally everything that isn't used. So if you don't have an encoder port that's used on a Spark Max, cover that up. If you're not using PWM on your Rio, cover that up. If you're only using 2 slots, E-tape everything else. If you have to drill or Dremel over the robot, or if you have, two pieces of metal on your robot that are grinding against each other and generating metal shavings, make sure you're vacuuming that and covering your Rio. Try not to have mechanisms on your robot that create metal shavings, but it happens sometimes. Again, it comes down to discipline, right? When you've got to do that quick fix, are you taking the time to cover the Rio and to, vacuum the source of shavings, right? Because everyone starts by doing this, but then they have to do a high pressure fix, and it just needs to be second nature. These things have to be, that you're either thinking about them to make sure you're doing it right, or that it is second nature, that you've built this culture so ingrained that it is just something you do. When you're creating metal shavings, you are not letting them get in your Rio. This is like actually super common, right? The number of metal shavings I pull out of Rios as CSA it makes me sad. So I would love to not have to do that at all this year. Connectors, the big thing here is, no matter what connector you use, tug test everything, right? Firmly pull on it. If you can pull on it, don't, put your full body weight into it, but give it a firm tug. If it wiggles, if it comes loose, redo it. If you do a power pull wrong and it comes out, don't reuse that power pull. Again, it's a 50-cent connector. Every match is $200, right? If you've got to yank something out of a power pull because it's not done right, just redo it. I like power pulls or Waco 221s, which are here for power. Different schools of thought. I think they're both just fine. Lots of good options for CAN connectors. I would say the main thing is if you're using just PWM terminals, either make sure those are locking or put retention clips on them so that they can't come apart easily in a match. I like these West Coast Products lever nuts, both for permanent connections and especially as quick fixes for CAN bus. Some people say hot glue, connectors in, like you plug a, like hot glue your RSL connector into the Rio. I think that's great. I don't know that we personally do it often. I think we probably should. Just make sure you only do a tiny bit. There were 888 had a Rio we found last year where every port had been filled with hot glue, and we had to, plier it out to try to get any of it out to try and actually use them. You don't need that much hot glue. A tiny dab will do to just, lock it in there. Strain relief. This is 1538 Holy Cows wiring. They're actually giving a wiring workshop in San Diego this week. Hopefully this recorded. This is so clean. I wish we could all be like this. But anything unsecured, right? If you have a motor controller unsecured, or even a lever nut unsecured, right? That's carrying a lot of mass that when you have a major collision and it goes flying, it's got the force to yank out a connector, right? This cost eSpots 3 ranking points at champs because we did a quick fix. We didn't zip die down a lever nut. We took a hard hit from another robot and it went flying and disconnected 2 of our sort of modules, right? So strain relief things, watch the bend radius on wires, especially a lot of the thinner wires like Neo encoder cables is one I've seen kind of particularly susceptible to when you bend it too much, it can break. And then just make sure that everything's mounted down, every component and every connector, right? You can kind of get away without doing it for kind of these just PWM connectors, but lever nuts, anything that's that massive or more, I would just secure it down, make sure that it can't go flying. So any questions on kind of electrical tricks or any thoughts on things that you all do to keep your electronics reliable? All right, let's move on to software then. So motor controllers. So the first thing is why does my Rio one? James post on the National Instrument Support Forum why your Rio one hates flashing over USB. So for motor controllers, the biggest thing is these have persistent settings. So if you in one season set a motor controller to have a current limit of 20 amps, and then in your code for the next year, and you save that to the motor controller, and then your code for the next year, you have that on that Spark Max on drive motor, and you don't explicitly set the current limit, it's going to come up with 20 amps as your current limit, and it might not be able to drive properly. So the first thing we do when initializing any motor controller, and this mostly applies to rev stuff, I don't know the CTR equivalent, although I'm sure it's there, is we factory reset the spark max. We set every setting we care about, and then we burn flash, which basically commits those settings to memory. If you don't do that, and the settings that are burned to flash are different, and you have a brownout, and your motor controller reboots, it can come up with an entirely different set of settings. So like I know 614 had this problem at one of their events this year where, a motor controller would get reset and it would come up in the wrong direction, and then suddenly they'd be driving backwards. So if you want to get fancy with this, by the way, because there is like a finite write count on how many times you can burn to flash, and it's like 10,000. I'm not too worried about that. I figure if we get 10,000 uses out of a motor controller, we're doing okay. But if you want to get fancy with it and extend the life, you can only do that when you're in an event connected to the field. But yeah, this is really important. So just make sure that you know what state your motor controller is in by resetting it, putting all the settings you want, and then committing it to memory on that motor controller. Current limits. This is a good way to protect your motors and motor controllers. Every motor should have a current limit, and you should know what it is. So for a Neo 550, you probably want that at 20 amps or lower. This picture is a link to the VEX motor test data where it kind of shows what safe current draws are for different amounts of time. If you set your current limit on a Neo 550 at 80 amps, it will smoke in basically a second. Whereas if you set it to 15 amps, you can stall at 15 amps basically forever. So this should be per motor and based off of what that mechanism is and what the motor data is. If you've got too much on your CAN bus, you can reduce status frame timing. I'll post links to how to do this as well. Make sure you're gracefully handling your peripherals. So if you've got a limelight and the limelight disconnects because, I don't know, your network switch dies or a wire got cut, that should not cause your code to die. You should handle that and say, hey, I don't have my limelight anymore. We're going back to manual control. Or I don't have my IMU anymore. I'm not going to completely freak out and drive in random directions. We're going to fail back to driving robot relative, and ideally notify your driver of this. I think 6328 has some cool notification stuff that like pops up in big on your screen. But just make sure you're error checking for when things disconnect, because they can and will, and just, handle that without your code just completely, dying. And test this, right? If you've got, code to handle a limelight disconnect, go there and unplug your limelight while your robot's running and make sure it doesn't die, right? Make sure it does what it's supposed to do. Watch your RAM utilization. So eSpotsman died on the field in quals like 25 of wake because we just ran out of memory. We're not quite sure how that happened, but I've seen it happen more times this year than I ever have before, and I'm not sure why. So a few things you can do if you've got a bunch of auto paths that you're not using, those hog some RAM, remove those from your code. If you've been setting on the field for 5 minutes, sometimes processes will just, eat memory. Reboot your Rio before the match. Don't make the FTAs too mad when you're doing this. Do it with enough time before the match starts. And if you've got crazy computationally expensive stuff, most teams don't, move that to a coprocessor. Mine are really sketchy. I don't think it's that sketchy though. This is a way you can get back like 50 megabytes of RAM by disabling some things that you're definitely not using. The Rio 2 has a lot more RAM. I don't know that I trust the SD card a lot, but other teams are using it without any problem. So if this is a big problem and you want to do computationally expensive stuff, just buy more RAM, I guess. And I think 4099, they were talking about this too, but log everything, right? After a match, something went wrong in software, and we're asking the drivers what happened, and I'm like, it felt funky, or robot was laggy, and we have no idea what that means because we have no insight into our code, logging helps with that, right? Because you can see, hey, this button was pressed at this time, and that corresponded with this internal state change, which corresponded to this motor not doing what it was supposed to. Let's look at why, right? You don't need to have full simulation capabilities to do this. Everything that's on Smart Dashboard can be logged if you set it to that. So it's really easy to integrate into your existing code. If you have, debug calls already to Smart Dashboard, you can make it cleaner, you can make it more fancy, but I would at least do the minimum, put a USB drive into your RoboRio and log to that. WPI libdocs cover this super well. Some stuff on driver station laptops. Have a dedicated laptop. I think eSpots has lost like 5 matches over 10 years because of various problems with, the programmer forgot to bring their driver station laptop, or their laptop is Windows updating. Have a dedicated driver station laptop that never leaves your driver station. Disable firewalls. This light should be green. These things should not be showing up. I would disable Windows updates entirely. I think you can go in and do that and basically say never ever update Windows. Do that in a controlled environment at home, not with your laptop blue screening and updating when you get on the field. Check your joysticks before every match. Make sure that your driver's joystick is mapped to the correct port. Your operator's joystick is mapped to the correct port. Don't go switching joysticks 5 seconds into teleop. That's a lot of time lost. $10 worth of time actually. And if your joysticks are having problems, you can hit F1 to rescan that quickly instead of fuddling around with your keyboard and mouse. Random thing, but I've seen it happen and it's super weird. Autodesk Inventor can cause you to have huge problems on the field because the update manager floods the network. So, keep your driver station laptop clean. Try to have as little as humanly possible installed on it, so that it is just driver station and nothing weird is going to happen. Driver station logs. I thought about talking about this, but the WPI libdocs cover this way better than I can. So they have good examples of what a normal log looks like, what an abnormal log looks like, what it looks like when your Rio reboots. So you should get familiar with this because it will help you debug what's going on. When I'm CSAing, that is the first thing I look at, right? A team says, we died on the field. I say, okay, can I see your driver station laptop and look at your logs, right? It is good if you know how to do that yourself, right? Because it can basically pull up 95% of things that fail. Like, there's clear signs of a radio reboot or a Rio reboot, or you had a ton of lag. Okay, well, your CAN utilization was at 95% and you were dropping CAN messages, or you had super high packet loss because you had 3 cameras streaming or something, right? So driver station logs combined with the field logs, which you can go and question box and ask the FTA, what did you see from your end during the match? Between those two, it's a pretty good way of figuring out what happened. You can see when your code restarts and error messages you got and loop overruns. Loop overruns are not necessarily a problem, but they can be. So the robot, runs code 50 times a second. Each loop has 20 milliseconds. If one loop every, few runs takes 21 milliseconds, it's not a big deal. But if you're in teleop and your loop is taking 50 milliseconds, then things are going to start getting funky, right? So it's not necessarily a problem if you have overruns, but I see it a lot. And you should look at what's taking up time in your code if you think that's causing problems. There was an ask for me to talk about how to look at stack traces. I'm going to record and post a separate video on that where I kind of talk through, go through a couple examples live. I think that's a better way of doing it than in this format. So I will have and post a video on this, hopefully before Christmas break. A few random things. 4607 Minnesota team has a really nice presentation on failure mode and effect analysis. And they talk about kind of, how they look at this failure analysis throughout the season and how they track like every single thing that failed at an event. This is a very good presentation. This is an excellent presentation on how you should approach reliability and failure. I was just looking at that. I'm paying more and more attention to shock mounting now. 900 did some analysis where they're showing that robots can undergo collisions at more than 60 Gs, which is, you know, if you like Formula One crash level. So that's a lot of strain on stuff. So, you know, we lost a district champs playoffs match because we took a hard hit and the PDH, like the plastic on the end, sheared off the bolts holding it in. So we're probably going to move to mounting stuff on like VHB tape and softer stuff, maybe nylon bolts rather than metal bolts, just to absorb some of the shock better. I'm not really sure about this. I think we're still learning a lot about this, but with how powerful robots are now and the, you know, propensity of swerve robots to crash into each other head on, I would start thinking about this more and more. Document all your connections. This is a really nice spreadsheet from 401 that Preston sent. You know, so put, hey, this is my drive motor. This is my front right turning motor. This will make your life easier when you're debugging things. It can often make inspectors' lives easier if they have anything to look at. It definitely makes my life easier if I'm saying, hey, PDH channel 14 is drawing 500 amps. What's on PDH channel 14? It's a lot easier if you have the spreadsheet rather than tracing through a rat's nest of wires. So have this both for yourself and for other people helping you. Other thing I forgot to mention, this status light quick reference page is your friend. It shows you basically blink codes for every device. Rev has one for their devices. This will tell you what is going well and poorly on your robot. Print this out, have it in a binder in your pin, have it bookmarked on your phone. Thank you, Preston, and thank you, my little brother, for the help on this. Any questions or tips that you have for keeping your robots running well?
Hear me?
Yes.
Okay. I think, I don't know if you covered this, but the Ethernet port on the radio is not good to use, the
Yes.
second one. You should almost certainly get a brain box. You might, okay, you went over it. Never mind. All good.
Any other questions? Pneumatics reliability. Okay, so what Preston wants me to say is pneumatics are bad. So I think that goes back to less things equals less failure. Pneumatics is a lot of components if you only use it for one or two actuations, and it may not be worth the additional risk of failure, or the simplicity of, you know, not having to really program it may be good. I am starting to see more and more with the options available that pneumatics is potentially becoming a little bit less important, but I'm not gonna swear off it or say all pneumatics are bad. I think just every part is a potential failure, every component is a potential failure. Pneumatics has a lot of part overhead, unless you do like 10 actuations with it. And if you do that many, then your part count may be lower than the equivalent number of motors.